All right, so here we are, beginning of our next unit on triangles and triangle congruence. So a couple things before we start. First of all, we may have done some of this in class, so if we did, you can skip ahead to wherever we left off. Second thing, you should always be prepared for our little entry ticket kind of pop quizzes. So make sure you're taking good notes. You're watching carefully. So at the beginning of the next class, if I do throw a little quiz at you, you are ready for that. All right, so the first page is a lot of stuff you've seen before, some vocabulary, just to make sure we're all on the same page that we can communicate together when we're describing certain types of triangles. So I'm going to show some notes, then I'm going to have you pause to write them down, and then we'll talk about them. So we know triangles, 3 sides and 3 angles. And you can classify triangles by the length of their sides or by the measures of their angles. So I will have you pause right now. Write these things down, and then we'll talk about them. So go ahead and pause now if you haven't. Okay, so you should have paused, written these definitions and drawn these shapes down. And if you haven't, please do that now. So scalene triangle, you can see 3 different side lengths and 3 different angle measures. And we haven't talked a ton about this lately, but these 1, 2, 3 slash symbols signifies that those are all different side lengths. And same thing with the arcs on the angles. The 1 arc versus the 2 arcs versus the 3 arcs means those are all different angle measures. All right. Isosceles triangles, 2 congruent sides, 2 congruent angles. So for the isosceles triangle, we have the 2 congruent legs. And you can see I kind of have another picture here where we'll talk about that in a second. But the 2 congruent legs, I have the 2 congruent slash marks on them. And then the 2 congruent angles are called the base angles. All right, so we have the legs and the base. And then we have the vertex angle, which is the one angle that's different. And then we have the 2 base angles, which are the 2 congruent angles in our isosceles triangle. So what you have to be careful for sometimes is the triangle is not always going to look perfectly like up and down like the one I drew there. All right, the one I drew in the example. In this case that I'm showing you right next to it here, these, I know we're like, if we go on that autopilot, we're going to look at that and say, oh, those are my congruent sides. But for an isosceles triangle, it depends where the markings are, where the information is that they gave us. So it looks like for this example here, those would be the congruent sides or the legs, right? And then these would be the congruent angles or the base angles. So it's not always going to be like look perfectly like, straight up and down like that. All right, equilateral triangle, 3 congruent sides, 3 congruent angles. Now what I marked in here was a little bit of foreshadowing. We talked about this earlier in the year, but we know a triangle's angles add to 180 degrees. So if I take that 180 and cut it into 3 equal parts, I know each angle has to be 60 degrees. So that's how I marked in those angles there. So if you need any more time, please pause. These are the terms you're probably a little more familiar with. So we're going to do the same thing. You're going to pause here. You're going to write those terms down. So do that now. Okay, so if you haven't paused, now is your time. Acute triangle, all the angles are less than 90. Obtuse triangle, one angle is greater than 90, right? They all can't be greater than 90. Otherwise, that would be too many degrees. It would be greater than 180. So one angle is greater than 90 in an obtuse triangle. And then a right triangle, this is some really important vocab for later in the year. One angle is 90 degrees. Just like isosceles triangles, in right triangles, we have 2 legs, and then we have the hypotenuse. All right, sometimes that word hypotenuse gets thrown around a little too much. The hypotenuse only exists in a right triangle. So it's the longest side of a right triangle, and it's the side directly across from the right angle. So there's your vocab. If you needed any more time, you should pause, but I'm going to move on. All right, So sometimes we're going to have to classify these triangles. We're going to have to name them carefully. So like, for example, we're not going to do all these, but if I look at this first one, I see I have these two congruent sides. So that makes the triangle isosceles. And then I have the one angle that's greater than 90. So this triangle would be isosceles and obtuse. So those vocabulary terms are things you're familiar with. I just wanted to do a quick reminder so we are all on the same page. All right, next rule, another one we talked about this year. Triangle sum theorem. The sum of the interior angles of any triangle is equal to 180 degrees. So angle A plus angle B plus angle C always has to equal 180 degrees. So we're going to see different types of problems with this. We're going to see them just solving algebraically. We're going to see them involving ratios. We're going to see some of the things involving parallel lines, like some of us used this year for some of those other strategies for the parallel line questions. We used triangles to help us solve those. So triangles are going to be very helpful for us when solving some of these problems throughout the year. So if we look at, let's look at number 2. If I'm just looking at what's going on here, I want to find the measure of angles, angle 1 and 2. All right, so first of all, we have to go back to all the old rules we've done throughout this year. If I see that 102, we think back to our linear pairs, right? So I know if this angle is 102 degrees, the two angles right next to each other off of a straight line have to add to 180. So if I do 180 minus 102, that gives me 78 degrees for this missing angle number 2. All right, so we have two of these angles figured out. Now, what I think about for these triangle questions, I think about is I have like a 180-degree budget. All right, we've used up 68 degrees, and we've used up 78 degrees of this budget. So to think about what I have left for angle 1, I just need to do 180 minus the angles I have used up, so minus 68 and then minus 78, and then that gives us 34 degrees for the leftover for angle 1. So that's all there is to it. Putting the pieces of the puzzle together, think about what we know. You know, sometimes there'll be a linear pair or like a vertical angle or some parallel lines. But when we have triangles involved, we know that those triangles are always going to add, the angles in the triangle are always going to add to 180 degrees. So you'll see questions like I mentioned with ratios, you'll see questions like this. So here it gave us the three measures, like it gave us these expressions representing each angle. So I know if I have angle A, angle B, and angle C, that's what this tells us, the measure of each of those angles. I know that these three angles together all have to add to 180. So I don't really need these parentheses here, but if we're thinking about exactly what's happening, just so I can show you, those three expressions added together have to add up to 180 degrees. So after we have it set up, now I can look at combining my like terms. So I have 3x plus 1x plus 2x is 6x. I have the minus 17, the plus 40, and the minus 5. So that gives me a plus 18. And now we're pretty much done. I subtract 18 from both sides. I divide by 6, and I get x equals 27. All right, so now being careful to answer the actual question, to find the measure of each angle and classify the triangle, just be careful. They want us to go back in and substitute 27 in for all my x's. All right, I know I'm going quickly through here. If you guys want to work through this on your own, you can pause the video now and try it out if you just wanted to check yourself. But if I plug in 27 for all those x's and I punch this into my calculator, we get 64 degrees for angle A, we get 67 degrees for angle B, and we get 49 degrees for angle C. So that would make this triangle acute because all the angles are less than 90. But it would also make it scalene because they're all different measures. All right, so we'll be using these triangles a lot this year. In all of our units upcoming, pretty much, we're going to be using this knowledge that the angles add up to 180 to help us. All right, and last little thing for the day, the triangle base angle theorem. So this basically just is it puts into words what we know about isosceles triangles. So in a triangle, two angles are congruent if and only if. So if and only if, basically it's like our two-way street. I talked a little bit about this, I think, in some of our classes this year. So basically it's saying if you, let's say, well, I guess let's say everybody in 10th grade takes geometry. I know that's not always true, but let's say if you are in 10th grade, then you must be in geometry. So I'm going to write 10th grade means you have to take geometry. So like I said, pretend that's true. I know it's not always true. But if it works the other way around, if I also say if you're in geometry, you must then also be in 10th grade, that's kind of what if and only if means. It means if it works this way, then it also has to work this way. So it goes both ways. It basically says if the sides are congruent, then the angles have to be congruent. And if the angles are congruent, then it means the sides have to be congruent. So kind of a way that I like to visualize this, if I kind of draw an arrow down here, it points you at the two congruent angles. So I have another example here where the triangles kind of turn sideways. Let me make it even a little bit, a little bit like that. So if I said that this side and this side were congruent, notice the base angles aren't always automatically the ones that are on the ground. I know we always think of like the base of something being flat on the ground. But in this case, if we look at my isosceles triangle here, if those are my congruent sides, these would have to be the congruent angles, which would make this piece here the base. All right, so just be really careful with that terminology. But looking at these questions, here's my congruent sides for number 1. That tells me these two angles opposite them are congruent. So if I have a 72 here, that means X also has to be 72 degrees. So pretty straightforward. And then to figure out angle Y, like I said before, I have 180 degrees total. I subtract what I've used up and see what's left in my budget. So 180 minus the two 72-degree base angles, and that gives me an answer of 36 degrees for my angle Y. Okay, this is just a coincidence. This 36 just happens to be half of the 72. It's not always going to be like that. All right, so that's it. And then, yeah, that's all the rules. Same thing here. There's my 110. I can think about what's left over, but the thing you have to be careful of here, there's two angles left. All right, those two congruent base angles. So if I take my 180 and I subtract what I've used up, which is 110, that gives me 70 degrees left over. But it wouldn't make sense for these both to be 70, right? That would put us way over our 180 degrees. So what I have to do, sorry about that, what I have to do is take my 70 and I cut it into the two equal pieces. So that tells me each of those angles will be 35 degrees. So there's your basics of triangle vocabulary. If there's anything you're having trouble with, let me know. But yeah, like I said, be ready in case we have one of those little entry pop quizzes next time. Otherwise, I will see you guys next time. Bye.